Hi, my name is Freddy Christensen. I'm a technical evangelist at the Microsoft Dynamics NAV team. I'm going to talk about load balancing the web client with application request routing. At the end of this video, you're going to understand how the traffic flows from the Internet Explorer or the browser on the user's computer to the web client when the web client is installed on multiple servers in an NAV service behind a load balancer and with application request routing or server farms installed on the IIS. So the setup that we're going to use is similar to the setup when we're using a redirect site. There are two servers in a cloud service. There's one port that is load balanced between both servers, which is 443, and then both servers actually have a web client on 443.01 or 443.02, depending on which server it is. In this case, you might be able to do without the actual public ports, so you just have the web client hosted on 443.01 on the actual server, so you don't have to actually open the public port in the cloud service. I normally do that, and that's primarily because then I can test the individual servers just by connecting to one port from the outside. But in this case, we're actually not going to use that port. So let's get the setup right. We have three clients connecting to our service, and they're going to type in the HTTPS myservice.navdemo.net, and the load balancer is going to select one of the servers. One of the servers is then going to hit the redirect site, which is actually taken here by application request routing, and ARR now forwards your request to one of the servers in the server farm. And in this case, it's going to select server number 1, and it's going to return what's called an ARR cookie, meaning that application request routing actually writes a cookie on the client's computer saying that last time you got server number 1, meaning that now that cookie will be sent to the server the next time in order to select server number 1 again. The second user now connects to the same URL, myservice.navdemo.net, and the load balancer selects server number 2, application request routing on that server forwards to server number 2, and returns an ARR cookie to the user's computer, which states that he uses server number 2. The third client connects to the same port. The load balancer selects server number 1. Server number 1 already forwarded to server number 1, so that one uses round robin as well, because we've set up the server farm for that. Here you actually can do various setups on that. You can set weights on the different servers to make sure that one server gets more connections than the other. But in this case, we're just going to give them equal amount of load. So this one is now going to select server number 2, and of course return a cookie to the computer stating that he uses server number 2. Now, when user number 1 connects again, he's going to get server number 2 by the Azure load balancer on port 443. But since he's sending a cookie stating that he wants to talk to server number 1, ARR, or application request routing, on server number 2 is actually going to forward his request to server number 1, and there he's going to now maintain a sticky connection to that one. User number 2 gets server number 1, but states that he wants to talk to server number 2, so ARR is going to forward his request to server number 2, and the same of course with user number 3, wants server number 2, gets server number 2 by the load balancer, and that one forwards the request to server number 2 because again of the cookie. So the flow will continue to run. The computers are going to connect to the same URL all the time, and they're going to be redirected to the server that they actually request in the cookie whenever connecting to the client. So it's going to look like this when they connect. In this case, we have 3 users and 2 servers, so it's going to repeat itself every 6 times, but you get the picture. You could have multiple servers, you could have multiple users. Every user would have a cookie stating which server he wants to talk to, and the application request routing installed on all the servers will then look in that cookie and see where to where to route the request from the individual users when traffic is coming in. In this case, the URL from the user's computer on the user's computer will remain the same, https myservice.navdemo.net, so we don't have to redirect him to a specific port or a specific server name. In that URL, we can actually use everything as it's typed. So the only place where this doesn't work in Microsoft Dynamics NAV 2013 R2 is that if you're using Azure Active Directory authentication, meaning AAD, then the web client is actually going to give the login of AAD the return address of the specific server, meaning that in that case you have to open the 44301 and 44302 ports, and you're not going to get the nice URL in the caption of the browser. So we've now seen how traffic flows from user computers from the browser on a user's computer to the web client when it's sitting behind application request routing. Thanks for listening.